Scenario-based environmental economic dispatch considering load and wind power uncertainties using NSGA2. This paper presents a multi-objective approach to solve the environmental economic power dispatch problem with voltage control for electric power system with thermal and wind power generators in operation. The main contribution of this paper are proposal of stochastic scenario-based programming structure to represent the environmental economic power dispatch problem, considering power load and wind generation uncertainties. Develop a specialized NSGA2 algorithm to determine a Pareto front that simultaneously minimizes fuel cost of thermal and wind generation, gas emission, and active power losses of a power system. Incorporation of voltage control devices through adjustment in transformer taps and shunts compensation in the environmental economic power dispatch problem. Propose and solve an environmental economic power dispatch problem formulation that simultaneously determines the optimal dispatch of active and reactive power generation. The uncertainties of power load and wind speed are considered through historical data of these parameters over a time resolution of 1 year. These historical measurements that estimate the behavior of power load and wind speed are divided into 4 subsets according to the season of the year. The K-mean clustering technique is used to reduce the information of each season into 6 centroids with a time resolution of 4 hours, and as a result a set of 24 representing scenarios is obtained to represent operational conditions of system. For each stochastic scenario, the environmental economic dispatch problem seeks to minimize 3 objective functions: the total cost of thermal and wind generation, the greenhouse gas emission, and the active power losses, while satisfying equality and inequality constraints imposed by different requirements of the power system. To solve the proposed stochastic environmental economic dispatch model is developed a computational tool based on the fast Elliott non-dominated sorting genetic algorithm. To efficiently handle the constraints of the problem, the feasible solution superiority technique is incorporated into the NSGA2. The proposal coding implies difficulties in simulating recombination and mutation. Thus, the linear recombination and random mutation are adopted. In addition, a fuzzy mechanism is used to extract the best compromise solution over the trade-off curve among 3 objectives. To validate the robustness and effectiveness of the proposed methodology, standard IEEE 13 bus and IEEE 57 bus test system are considered. The details of this power system and the basic parameters of wind farm are listed in Table 1. The figures 2 and 3 represent the first Pareto front and the best compromise solution obtained for the IEEE 30 bus and IEEE 57 bus test system, respectively. As conclusion, results show a set of non-dominated solutions organized in a Pareto optimal front, reflecting the conflict among the considered objectives and the non-convex feature of the problem. The insertion of wind sources contributes to mitigating greenhouse gas emission from thermal energy production. The optimal active and reactive power dispatch of thermal units significantly reduces the generating cost and environmental impact of the system. The voltage control through optimal adjustment of tap transformer and shunt compensation improves the power losses of system and contributes to reduce greenhouse gas emission.